Songyuan. It is my pleasure to present my work on ACM UbiComp conference. I'm Songyuan Li from Zhejiang University. The title of my presentation is Data-Driven Battery Lifetime Aware Scheduling for Electric Bus Fleets. First, I will introduce the background. According to the research, about 8.4 million electric vehicles will be used globally in 2025. However, battery degradation is a severe problem of electric vehicles, which hinders its development, especially for electric bus. Compared with the other electric vehicles, it has more frequent overload. This leads to booming discharge current. Thus, the battery degradation problem is more severe on electric bus. For example, BYD K9 has a 10% battery capacity degradation in about 2 years. Motivated by this, we propose such a battery lifetime aware electric bus scheduling system. Let's see the motivation extracted from our datasets. Firstly, the passengers show boarding demand imbalance from both temporal and spatial view. Then, the boarding demand imbalance reflects to passenger load imbalance for all electric bus. Passenger load imbalance leads to large discharge current on batteries, thus results in quick battery degradation rate. So in this work, we intend to schedule the electric bus fleet properly to balance the passenger overload, to balance the passenger load, so that the battery degradation rate can be improved. This is the system overview. Taking these design challenges into consideration, we propose the system architecture. It is composed of 3 parts: sensing, computing, and operation. Then let's introduce the detailed design of our system. Here is the battery lifetime aware scheduling modeling. First, we have the passenger overload analysis. Then we have battery degradation modeling. This process includes electric motor behavior and battery capacity degradation. Including these constraints, we have the following optimization problem. The objective is to minimize the average battery degradation rate. In order to provide a real-time scheduling scheme, we must precisely predict the passenger arrival rate. Here, we first apply k-means method to extract bus station locations from our datasets. Then we obtain the passenger arrival data. We select time step, weather, and holiday as our predict features. We apply profit as our prediction model. This is a modular regression time series prediction framework. Here are the prediction results. Then we introduce the electric bus scheduling algorithm based on the Lyapunov optimization. Lyapunov optimization is a network optimization method which can solve spatial temporal coupling problems. It has 2 usage conditions. According to our problem, we select passenger waiting queue at each bus station as virtual queues, and the objective is the average battery degradation rate. This is a time average form, so we can apply this method here. According to our derivation, we reduce the primal problem to a mean kill problem, which can be solved in polynomial time with deterministic bounded queue and probability guarantee. We also notice that in practical implement, we have the estimation errors of some important parameters. We prove that our system can tolerate these errors. Then we present the data-driven evaluation. It's clear that our system has a 20% battery degradation rate reduction with pretty good passenger service quality. This means that our system can extend the battery lifetime of electric bus for 1 year. Our system shows stable performance on different bus lines. It also shows good robustness on different available bus settings and time horizon. We also present insight analysis. Our system successfully forecasts the incoming peak hours and provides relative adjustments in advance. Good performance is due to smooth discharge current caused by small passenger load variance. Finally, we conclude this paper. In this paper, we propose a novel data-driven battery lifetime-aware scheduling system. We provide precise estimation of passenger behavior. We design a near-optimal solution with reliable performance guarantee. And finally, we provide extensive evaluation based on practical datasets. That's all for my presentation. Thanks for your attention.